Hey, what's up, guys? We are WRIM. Our lightning talk will be on PEP 492, coroutines with async and await syntax.
Our presentation is on PEP 492, and it proposed to make coroutines a standalone concept in Python. It was created for version 3.5, and it was added to the language in 2015. The general intention behind this was to create a syntax that would easily support asynchronous programming in Python, and would also allow Python to be more like a synchronous programming language.
Some of the goals of this PEP include internet and general connectivity growth, the need for responsive and scalable code, and helping keep Python relevant and competitive in the area of asynchronous programming.
So what is a coroutine? A coroutine provides a control state between calls. They act similar to threads in how they work. The difference is that one coroutine can be run at a time, threads can be run in parallel.
So this PEP makes a few assumptions about coroutines. Number one, asynchronous tasks are scheduled and coordinated by an event loop. And it assumes that coroutines use the yield keyword as a signal to the scheduler.
A little bit of history. Python's previous answer to coroutines was PEP 342. It changed the yield expression and added new methods. New functionality was added in PEP 380.
The previous implementation was based off of coroutines that use generators. They wanted to move away from this because the only way to distinguish a coroutine from a generator was a yield statement that would disappear during refactoring.
Why the use of async and await keywords? Well, async and await is not a new concept in programming languages. C# has had it for a long time. It's featured in Facebook's Hack, Google Dart language, and Scala, and there's a proposal to add it to C++. Some more properties are that async defined functions are always coroutines, even if they do not contain await expressions. It is a syntax error to have yield or yield from expressions in an async function, and regular stop iteration and exceptions are not propagated out of coroutines and are replaced with a runtime error. When a coroutine is garbage collected, a runtime warning is raised. Why not reuse for and with statements? The idea behind existing generator-based coroutines in this PEP is to make it easier for users to see where the code might be suspended. Making existing for and with statements recognize asynchronous iterators and context managers will inevitably create suspend points.
There were several higher level changes. Specifically, asynchronous definitions were added and AST nodes were updated to include asynchronous functionality. In addition, the CAPI was updated to include coroutines on their own, as well as to add bit flags and for coroutines and iterable coroutines.
So this is the new syntax to declare a native coroutine as defined by this PEP. Some keys to remember: any async defined functions are coroutines, and async defined functions don't have to contain await expressions. And here's the syntax of a generator-based coroutine. This PEP also adds a new function type coroutine to the types module. This allows for interoperability between existing generator-based coroutines and async IO and native coroutines introduced in this PEP.
This is the new await syntax. It suspends exceptions on functions like read data. It awaits to complete and then returns results, similar to the yield function, except it validates first.
And here's the new updated operator precedence for the await keyword. Some examples of parsing the await expression. Key difference between the yield expression and generator coroutines and the await expression is that await expressions generally do not require parentheses.
As with any language update, the grammar associated had to be updated as well. Specifically, async definitions, async functions, await definitions were all added to the grammar.
If you wish to read more about PEP 492, go to these sites. We used them in our research and found them useful. Thanks for watching, guys.
Thanks.